Hi everybody. In this video I'm going to give a brief introduction into 5 common reaction types. In upcoming videos I'll go into more depth and greater detail into each of these different types. Our first reaction type is called synthesis, and it has another name. It can also be called combination. In a synthesis reaction, one of the key features is that everything combines into forming only one product. One way to think about it is in terms of a relationship. You have boy meets girl and then forms a couple. Now for the purposes of my class, what we're going to do is I'm only going to give you synthesis reactions where you're forming an ionic compound. And that's going to allow you to predict what the product is simply by doing a little T-chart where you balance off the charges. For our next type of reaction, it would be a decomposition. Now a decomposition is the opposite of a synthesis reaction. What happens here is that you just have one overall reactant and it's going to break down into smaller pieces. Using the relationship analogy, what you'd have is a couple just breaks up. We also have a single replacement reaction, and that's when one element is going to trade place with another element in a compound. If you still want to try to use the relationship analogy, what you'll see is that a new person comes into town, breaks up the existing couple, a new couple is formed, and one from the original couple gets left out. So what you'll see in this pattern is that you'll always have one that's an element and one that's a compound for the reactants, and the same thing for the products. There's going to be one that's an element and one that's a compound. This brings us to our fourth pattern, the double replacement reaction. And what you'll find here is that an analogy that could be used is like a square dancing analogy. What you have is a couple, AB, and a couple, CD, and they just switch partners, so now you have AD and CB. What will happen is that the anions, those were the negatively charged ions, and the cations, those are the positively charged ions, will just wind up switching places. As you can see from our example, what we have is we always have two substances that are compounds on the reactant side, two substances that are compounds on the product side, and what you'll see is that you're going to wind up combining the outers, so the PB and the I go together, with the inners, and so you'll see that the K and the NO3 go together. Our fifth and final pattern is the combustion reaction, and we're going to focus only on the combustion of hydrocarbons and only on complete combustions. So a combustion reaction is one where oxygen combines with a fuel that's going to contain carbon and hydrogen, and so those compounds are called hydrocarbons, and you're only going to form carbon dioxide and water. All these reactions wind up being exothermic, meaning that they're going to produce heat. And one of the things that you probably have heard about before related to combustion is that you always need oxygen to support combustion, and so that's why you'll see it there as a reactant.